All right, let's dive in. We're going to talk about the incredible system we humans came up with to make sense of the vast, wonderful, and sometimes just plain weird world of living things. It's really a story about finding order in the most beautiful chaos you can imagine. And honestly, it does leave you speechless. I mean, our planet is just packed with this awe-inspiring diversity of life. It's everywhere, thriving in places you wouldn't even think possible, from the insane pressure of the deep sea to the freezing thin air on top of mountains.
And to put a number on it, get this. Scientists have already identified and described somewhere around 1.8 million different species. And that's just what we've found so far. We're discovering new ones all the time.
That's the million-dollar question, isn't it? With literally millions of organisms out there, how in the world do you even start? It's a huge challenge if you want to study them or even just, talk about them without getting totally confused. So the very first step, the ground floor of this whole project, was to solve the name problem. Because if we can't even agree on what to call something, how are we ever going to study it together? Yeah, relying on local names is a recipe for disaster. What you call a gopher in one place might be a prairie dog somewhere else. It's total confusion. So scientists needed a universal system, something every biologist on the planet could agree on. And the solution they landed on, pioneered by the brilliant Carolus Linnaeus, is called binomial nomenclature. It sounds fancy, but it's simple. Bi for two, nomen for name. A two-part name for every single living thing. Pretty elegant, right? And the system has just a few simple rules, which is why it works so well. The names are in Latin, they have those two parts, genus and species, and the capitalization is always the same. It's like a universal grammar for all of life. So, for example, a mango isn't known by hundreds of different local names in the scientific community. Nope. It has one name and one name only, Mangifera indica. Simple, clear, and everybody knows exactly what you're talking about. Okay, so a universal name is a fantastic start. It's like we've given every book in the library a unique title. But now we've just got a massive pile of books on the floor. We need a filing system, a way to organize all these species we've named. And that process is called classification. It's all about grouping organisms into convenient categories, which scientists call taxa, based on characteristics they share. It's just like sorting those books by genre, fiction, nonfiction, mystery. This whole shebang falls under the science of taxonomy. It gives us the complete game plan for understanding an organism, from describing what it looks like, to figuring out what group it belongs to actually classifying it, and finally giving it that official two-part name. Okay, let's actually look inside this great filing cabinet and see how it's set up, because it's less like a simple list and a lot more like one of those Russian nesting dolls, where each one fits inside a bigger one. Right, so classification isn't just one step. It's a whole hierarchy of ranks, kind of like a ladder. And each step you take up that ladder, the category gets broader and more general. And these are the main rungs of the ladder. It goes all the way from the most specific group, the species, up through genus, family, order, class, phylum, and all the way to the broadest category, the kingdom. A good way to think about it is like a complete address for any organism, from the kingdom being the country, down to the species being the exact house number. So let's make this real with an example. A genus groups together species that are really, really closely related. Take lions, leopards, and tigers. They share so many features that they all get grouped together in the genus Panthera. Now, if we climb one step up that ladder, we group related genera into a family. So the big cats in the Panthera genus and the smaller cats, like house cats, in the Felis genus, they all get bundled together into the bigger cat family, Felidae. Makes sense, right? And this brings us to the golden rule of this whole system. It's super important. The higher you climb that ladder, from species up towards kingdom, the fewer things the members of that group have in common. A tiger and a lion? Tons in common. A tiger and a housefly? Not so much. But hey, they're both in the animal kingdom. But here's the thing. This system is so much more than just a neat way to put things in boxes. The very act of organizing life like this led to this incredibly profound, absolutely beautiful understanding of what life on Earth actually is. Now, this table shows you the true power of this system. Just look at it. The same ranks, genus, family, order, are used to classify things that are wildly different. We can map out the address for a human, a housefly, a mango, and wheat using the exact same structure. It is a truly universal language for all of life. And that right there illustrates the most important, honestly, the most mind-blowing discovery that came out of all this sorting and naming. It was never just about being organized. By carefully organizing life based on what it shared, we stumbled onto a fundamental truth. All living things are related. We all share a common history. I mean, what a humbling discovery. And it directly led to our modern understanding of evolution and this urgent feeling that we need to conserve biodiversity. So that leaves us with this final, fascinating question to chew on. This incredible system has helped us make sense of the 1.8 million species we know about. But what new secrets, what new connections about life will be revealed by the millions of species we haven't even found yet? The Library of Life is massive, and we've still got a lot of exploring to do.